Hi guys, this is Mrs. Tellas. This is covering section 9.2, which is solving quadratics by graphing. So we're going to be using our graphing skills from chapter 8. So we've actually talked about this before. Use graph to solve the equation. So if we look at the graph that's already graphed, what we're looking for is we're looking to see where the graph crosses the x-intercept. So you can see in this first example, number 1, that the graph crosses at -2 and +1. So those are my two solutions, and you can see it very clearly. They cross here and here. And on the second one, number 2, you can see that it crosses at -1 and +3. So our solutions are where the graph crosses the x-axis. And lastly, on this last one, it crosses at 0. This one is a perfect square. I know that because it only crosses one time. The vertex is sitting on the x-axis. So the solution here is 0. If you remember from before, solving means to name the x-intercepts, like what we did up here. So the other names for the solutions are x-intercepts, roots, and zeros. And we talked about that when we were still in class together, so I'm hoping it rings a bell. All right, standard form of a quadratic is y equals ax squared plus bx plus c. Okay, when we do this, we're going to set this equal to 0 rather than y when we're putting in standard form, because if you notice down here on the questions, there aren't any y's. So what I want, most important here, is that a is positive. So I want to keep a positive. So if it's already positive on the side it's on, then I want to keep it there and move the other things towards it, the other terms. If it's negative, I'm going to move that term to the other side. And it doesn't matter if the bx and the c are positive. The most important one that's positive is the a. So here I'm going to subtract 18 on both sides. So my equation in standard form would be 3x squared minus 18 equals 0. Here, if you notice, 4 is negative, so I need to move it to the other side. So I'm going to add 4x squared. So 5x equals 4x squared plus 6. And I still need it set equal to 0, so now I need to subtract 5x, both sides. So 0 equals 4x squared minus 5x plus 6. And that's in standard form because, remember, I got to put it in order of exponents. So x to the second is first, x to the first is last, and the constant is next, and the constant is last. All right, and this one. So notice this is a -2 x squared. So I'm going to move it to the other side by doing the opposite operation, which is plus. So 0 equals 2x squared plus 8x minus 1 is my answer. All right, so now we're going to get into the meat, and most of your questions are like this. So first thing we want to do is make sure it's in standard form, which it's not. X squared is positive on this side. I know it opens up like a smile, but the 3 is on the wrong side, so we're going to subtract 3 on both sides. So I'm going to get x squared plus 2x minus 3 equals 0. This is what I'm graphing. So I want to use my formula for finding the vertex and the line of symmetry. So x equals -b over 2a. So -2 over 2 times 1 is -1. So the first part of my vertex is -1. And then I take -1 and I plug it in here to come up with my y. So -1 squared plus 2 times -1 minus 3. So if we type that into the calculator, so that would be 1 minus 2 minus 3. That gives us -4. So remember what I'm looking for. I'm actually looking for where the graph crosses the y-axis. So I'm going to put my vertex right in the center. So up one and up another, and back one and back another. So now we're going to plug either the 0 and 1 or the -2 and the -3. The 0 and 1 seem easier, so I think I'm going to plug those. So if I put 0 in there, 0 squared plus 2 times 0 minus 3 is -3. So that one's -3. And if I do the same thing for +1, I'm going to use my calculator here. So 1 plus 2 minus 3 gives me 0. Okay, so if I graph it, -1, -4 would be left 1 and down 4. 0, -3. -2, -3. I still haven't found it. I want to know where it crosses the y-axis. And the last 2 points give it to me. 1, 2, 3 to the left. So my axis of symmetry is y equals -1 right here. Excuse me, x equals -1. And my solutions are right here. +1 and -3. Those are my solutions because it's where the graph crosses. Okay, so let's do this one over here. This timer's in my way. Here we go. Also, let's change colors. All right. So first thing we want to do is I'm going to move both of these to the left because x squared is positive over here. It's keeping the parabola going up, and I would really like that. I always want that a to be positive where it can be. So I'm going to add 7x to both sides of the equation. And then also add 10. So my equation is x squared plus 7x plus 10 equals 0. And now the vertex. X equals -b over 2a. So that's -7 over 2 times 1. So that's -7 over 2, which is -3.5. Right, so now I'm going to plug that in my calculator, or first I'm going to write it. -3.5 squared plus 7 times 3.5 plus 10. So let's see, -3.5 squared plus 7 times 3.5 plus 10. Ooh, that's a terrible one. Let me type that in again. I got 46 point something. Let me try that again. Let's see, -3.5 squared plus 7 times -3.5 and then plus 10. This time I got, that's better, -2.25. That's not so bad. Although I don't love the decimals, but it'll work still. All right, x and y. So we're going to put -3.5 here and -2.25 here. So I think I will go up to -2.5 and up again to -1.5 and see if those work. And I may have to go further because I really want this down here to be 0. So let's see. If we plug in 2.5 here instead of 3.5, I have a lot of room, so I'm just going to change that. So here we go. I'm using the calculator. -2.5 squared plus 7 times -2.5 plus 10. That gives me -1.25. And I could put -4.5 here and it would give me the same thing. And I'm going to scroll back and try -1.5 and see what I get there. So that gives me 1.75. Let me check that again just to make sure. Yeah, that's exactly right. So we don't have a specific 0, but we can tell that it crosses in between here. We just don't know exactly where. We could maybe try -2 and see if we can get -2 to work. Let's try that because -2 is between -2.5 and -1.5. So again, I'm going to type it in. So -2 squared plus 7 times -2 plus 10. Ah, there it is. The magic spot is -2, 0. Which means if this is the vertex, that means that here is also 0. Oh, that's a 5, not a 4. There we go. That makes sense. All right, so if I plot it, I got a little decimals going on here. So -3.5 would be left, 1, 2, 3.5, and then down 2.25. About right there, a little less than halfway down between 2 and 3, -2 and 3. So then I've got -2.5, 1, 2.5, down 1.25, so about there. -2 is 0, and -5, 1, 2, 3, 4, 5 is also 0. So here I've got negative 4.5. 1, 2, 3, 4 and a half, down about there. So you can see from the picture, and you can also see from the table, that my solutions are negative 5 and negative 2. And remember, you don't want to put parentheses because parentheses mean that it's an ordered pair, and these aren't ordered pairs. These are actual solutions or roots or zeros. All right, 2 more, and then we're finished. Okay, so let's move this 4x over where x squared is positive. So this equation is x squared minus 4x equals 0. Notice that there's no c, so c would be 0 if we needed it. So x equals negative b over 2a gives us negative negative 4 over 2 times 1, which makes it positive 2. 4 over 2, and 2 negatives make a positive. So let's plug the 2 in. 2 squared minus 4 times 2. So that's 4 minus 8. That's a negative 4. So let's make our table. 2, 3, 2, negative 4. So up 1, up another, back 1, back another. So that would be our zeros. I can tell since there's no c, if I plug these in, there would be 0 minus 0, and then there's no c, so it's 0. So I could find 1 and 3, but I really don't need to. I already have it graphed with the 3 points. So 0, 0, 2, negative 4, and 4, 0. So there's my picture. And my 2 solutions are 0 and 4. Okay, last one. So notice that this one's got a negative x squared. We want x squared to be positive, so we're going to add it to move it to the other side. So my equation that I'm going to work with is equals 0, x squared minus 2x plus 1. I think this one's going to be a decimal. Maybe not. Let's give this one a try. Actually, it might be a perfect square. Let's take a look. So finding the vertex. Negative b over 2a. So that's negative negative 2 over 2 times 1. So we've got a positive 1. 1 comma something. So let's plug our 1 in. 1 squared minus 2 times 1 plus 1. So 1 minus 2 plus 1 is 0. We found it. So that means that it's sitting on the vertex, which means it's a perfect square. So there won't be a symmetrical point. It's going to graph up here somewhere. So let's go ahead and get 2 more points, and then we'll have it graphed, just because we already know what the answer is. So if we put 1, 0 in the middle, 0 and 2. So 0 is our easiest one because the answer to 0 is just C, and C is 1. So that's 1 and that's 1. And that's as far as I'm going to go. I already have the answer. So 0, 1 is here, and 2, 1 is here. So there's my cute little parabola. And my solution is just positive 1. There's only 1 solution because it's a perfect square. So I hope you're catching on. It really is a bunch of chapter 8. You're using your vertex formula to graph, and you're looking specifically for the point that gives you 0 for y. So you're looking for that every single time. Where y is 0, that x is the answer. Where y is 0, that x is the answer. Same thing on these. Where y is 0, the x is the answer. Okay, so those are the x-intercepts, and this is how you solve by graphing. Remember, if it's already solved, you just look at it and see where it crosses the x-axis. So this is kind of review. I hope you thought this one was easy. So the assignment is on Big Ideas Online. It's page 494. 5 through 8 is just looking at pictures and saying what the assignment is. And then 13 through 26, you're going to solve by graphing. So I hope it's a good day and you understood. And if you have any questions, I'm online from 12 to 1 every day. Feel free to get on there. And if you just want to chat. All right. See you soon, hopefully. Take care. Bye-bye. Bye-bye.